Am I audible? Hello?
Yes, yes, you're audible.
Okay. Please confirm whether the screen is visible or not. Wait, I am having some problem. Is the screen visible?
Yes, it's appearing.
Okay. Thank you
Yes.
for the confirmation. Okay, so today we are going to discuss the multivariate and we are going to do a brief recap of whatever we have learned. Basically, we know that what is there in multivariate. We are just recapitulating the basic things of multivariate and we are just going to state the results, not going to go in the deep of all the results, but we are going to highlight few of the important results. Okay, so we are just writing the basics. Let X alpha curl be a P cross 1 vector which follows a P variate normal with mean sorry with mean mu alpha curl and the variance covariance matrix sigma, where sigma greater than 0, that means it's a PD matrix for all alpha running from 1 up to n independently. So two things are over here very important. That is this thing. This is PD, and these all for all alpha running from 1 to n. That is for n vectors we have of this order p cross 1. All are having this particular normal, and all are independent. So how basically my capital X actually look like? My capital X actually looks like it's basically a matrix of order P cross N, whose each and every column is actually a vector x1 curl, x2 curl, and it is xn curl. And we have actually seen this, that this each of this xi curl actually follows. Mm, Just a minute, my pen tab is not working properly. And each of these xi curl actually follows this normal with p variate normal with mean mu curl, mu1 curl and mu2 curl, rather mu alpha curl for alpha running from 1 to n, and sigma. Excuse me for 1 minute, my pen tab is having a problem. I'm just coming back. Just excuse me for 1 minute.
Yeah, sure.
Am I audible?
Yes.
Extremely sorry for this technical glitch. My printer was not working. I have to just you have to wait for some time. Sorry.
It's no, not an
Okay.
issue.
I hope it's visible now.
Yes.
Okay, so this is actually called my data matrix. Okay, this is actually called my data matrix, and what we are actually having over here, this dispersion of any x alpha curl, that is any of this vector, is denoted by sigma, and this covariance of any x alpha curl and any x alpha prime curl, obviously where alpha and alpha prime are not equal, is basically 0, where alpha is not equals to alpha prime. Okay, this is normal zero, not any vector, since we are denoting it by covariance. So we are now defining it in matrix notation. So we are defining it in matrix notation. মা বাবার হাতের দিকে তাকাও, আমার চারটা so it's x curl. So what we have basically this x curl. Mm, just a moment, I am starting a new section. Okay, my printer is not working. Just one more minute. Again, it's not working. Let me check the pen again and I'm coming back. Sorry for this. Is it okay now?
Yes.
Very sorry, like it's not working. I don't know what's happening. I need to check it after the class actually. Okay, so this is x1, p cross 1 curl. This is x2 curl, which is again p cross 1. And in this way, we are actually proceeding and getting xn curl, which is p cross 1. Okay, so these are my x curl, which we are saying to follow in p. P and there is some in, like vectors are there, so that with mean vector, which is mu1 curl, mu2 curl, and obviously mu n curl, comma, and we are actually going to have something which is a very big matrix. I am writing it over here, a matrix
Is
whose
that
like yes, hello.
X star code?
It's
X.
Starker. Yes, I'm just renaming it.
Okay.
I'm just renaming it. It's actually a vector whose follows. It's a multivariate normal, right? So
Yes.
not only one variable. So one what we have learned, how the transformation is actually coming. We first of all we know that a single variable following some normal mu sigma square. Then we have learned some x curl following some normal of p of some mu curl comma this.
Yes.
Now we are dealing with we call some univariate case,
Yes.
and this we call some
Multivariate.
multivariate case. Now what we are actually doing, we are just taking this is a single vector, right? Basically, now what we are saying over here, we have in suppose this is a vector of order p cross 1. Obviously this denotes that this is a vector of order p cross 1. We are saying that we have n vectors, okay, we are saying that we have n vectors with us. Okay, is it okay? We are saying that we
Yes.
have n vectors with. Is it visible? Again, the pen tab. I am having too much problem with my pen tab today. Okay, I'm just briefing it out. So we are having n vectors like this. So that is generating a multivariate normal setup. So that n vectors are these vectors, which is actually following a mean vector, or basically it's going to be a matrix kind of thing, whose each and every row is particularly a vector, and this is nothing but again a matrix whose first this is actually a PD matrix of sigma, which is the dispersion of this particular first vector, and the other sets, these are like null matrices. The other corresponding places are filled up by this null matrices. Okay, and then this is going to be my sigma, and the other places are again filled up by null matrices. Okay, again the pentam has started doing a problem. Okay, so I'll write it over here. It is going to be sigma over. Okay, so it's basically nothing but this sigma. Again, it's going to be 0 and so on. Okay, so this is also a big kind of matrix, and this is the normal thing. So what we are going to do over here, we are concerned about let L curl n cross 1, which is obviously not a null vector, is be a fixed vector. Then we need to find the distribution of y curl, which is of order p cross 1, which is a linear combination of this thing. Basically, this was my the data matrix n cross p, capital X of order n cross p into L curl, and this is called my multivariate like multivariate linear function in X curl. That in X. Okay. So like what we used to get a multivariate linear combination for a single vector, here we actually used a data matrix. This was my data matrix. And this was a vector which we have defined over here. So this was multivariate linear function in capital X, the data matrix. Okay, so now what we are actually going to do, we are going to find out several results based on this thing. So our main concern is we have actually obtained something which is called y equals to capital X into L. So this is the main thing, and we are concerned about the mean, and we need to find the mean and dispersion of this thing. But these are not like normal things. These are matrices. This is of order P cross Q. This is N cross P, and this capital L is going to be N cross Q. Because instead of having a single like L curl, we have taken capital L of order N cross Q, which is a combination of L1 curl, L2 curl, and LQ curl. Okay, so we are actually concerned of finding the distribution of this thing. Is it okay? Now, what we are actually doing over here, we are basically trying to find a particular element of this particular setup. These are like all matrices. So if I wanted to find a particular element that is going to be a particular vector yi, which I am writing at x into li curl. So that is nothing but summation over alpha running from 1 to n li alpha x alpha curl. If I'm just going to expand this, because already xli, whatever is xli, I have written it over here. This is my xl curl. So this is my xli. So that is nothing but summation over li alpha for any alpha vector of this thing. So if I wanted to find the expectation of this particular yi curl, then I will be writing summation over alpha running from 1 to n L I alpha, there will be a dual suffix of expectation of x alpha curl, this thing, and that is going to be alpha running from 1 to n L I alpha mu alpha curl, because expectation of x alpha curl is mu alpha curl, and that is going to give me something like this: mu1 curl, mu n curl, and this is li1, li2 up to lin, and that I am writing as a capital M, because these vectors collaborated with this particular thing is going to give me a matrix again, which I am writing as M of order P cross N. You can check the order, which is Li curl, which is N cross 1 for all I running from 1 to Q. Okay, so this is expectation of yi curl a particular element. Similarly, we can go and find dispersion of yi curl, dispersion of yi curl, which is actually variance of yi curl. So basically this dispersion is actually going to be my summation over Li alpha, this particular thing, into X alpha curl, and we need to find out the expectation of this X alpha curl with respect to this Li curl will go out of the variance, but we will have a covariance term with it, which we have already defined earlier, and that is going to help us in finding the variance term itself. So we are actually going to find out this dispersion of yi curl, which is variance of yi curl, and we are going to write variance of summation of Li alpha X alpha curl, alpha running from 1 to small n. This is the thing. So basically this is not that simple, because there will be a covariance term with X alpha transpose, which we have already defined. So let us write this first term, where alpha is equals to alpha prime, which is variance of Li alpha X alpha curl. This is the first term, and next term is Li into X alpha curl, comma Li alpha prime X alpha prime curl. So this is the covariance term, which we have already know that it is actually 0, because these particular things are independent. So without knowing that what are the things going to come later, we are just writing simply this covariance to be 0. And this variance of X alpha curl, let me write this, plus summation of alpha running from 1, summation of alpha prime running from 1 alpha n, and this is going to be Li alpha prime covariance of X alpha X alpha prime, this thing. So what we came to know, that this portion is actually 0, since all the setup is independent, and this portion gives me sigma, that is the dispersion of the individual x vectors. So this portion 0 will imply that the whole portion is 0. So we are going to only left with alpha running from 1 to n x Li square into sigma. So that is the thing, because that portion is particularly 0. Okay, so now this is something variance of yi. Okay, Now we need to find out variance of yi and covariance of yi and yj as well. We didn't say covariance of yi and yj is 0 or not. We didn't check that. We only have checked this x alpha and x alpha prime as 0. And y is a combination of this capital L and x. So we are not sure that whether any term or any particular vector yi and yj for I not equals to j from this setup y is going to be independent or not. For this, let's check this out. Yi comma yj curl is equals to covariance of summation over alpha running from 1 to n L I alpha x alpha curl summation over beta running from 1 to n L j beta x beta curl. This thing that is equals to, first let takes out the summation, x alpha L j beta covariance of x alpha x beta. So as you can see, here we are going to get two separate portions. When alpha and beta are equal, this covariance is going to generate variance. This actually is going to generate variance when alpha is equals to beta, and going to generate covariance when alpha is not equals to beta. And obviously this covariance term is going to be 0, because we have done the same thing. Instead of beta we have just written alpha prime, so it doesn't make difference in the name. So basically that is going to be alpha running from 1 to n. We can take any of the suffix alpha beta, there is nothing in the name. So L j alpha variance of x alpha curl. Again the problem has started. Variance of x alpha curl thing, plus here it is alpha running from and beta running from 1, where alpha is not equals to beta, up to n L I alpha L j beta covariance of x alpha curl x beta curl. So this portion gives me 0. So the entire portion is actually 0, and we are left with summation over alpha running from 1 to n L I alpha L j alpha into sigma. This is the variance portion. So this is the covariance of xij yij. This particular portion is over here. Okay, so what will be the distribution? This is the mean and variance of a particular variable yi or yj, what we have actually obtained. Now we need to obtain the entire variance, mean and everything of this particular like setup of the y curve. Okay, so we are now proceeding for obtaining this thing. Okay, so basically, we are writing it as y curl star, which is of order pq cross 1, is going to have a mean, which is my y1 curl of p cross 1, y2 curl of p cross 1, and yq curl of p cross 1. I should have written it as a column. Since I have written it as a row due to the space constraint, I have given a transpose of it. Okay, so that implies basically expectation of y curl star is basically m into L1 curl, m into L2 curl, and m into LQ curl. This is the transpose of it again. You should have written all the things in column, or otherwise, if you are writing it in a row, you should give a transpose of it. And next is dispersion of y curl star, that is going to be L1 curl transpose L1 curl sigma, L1 curl transpose L2 curl sigma, and so on. L1 curl transpose LQ curl sigma. Next line will be, here is going to be, this going to be a symmetric matrix, so we don't need to write the lower part of this, so it's sufficient to write the upper triangular part. L2 curl transpose L2 curl sigma, and L2 curl transpose LQ curl sigma, and so on. This is going to be my dispersion of y curl star, which is of order PQ cross PQ. So we actually have obtained the distribution of y, which was my x into L. So basically we have obtained the distribution of y equals to x into L, where we have already defined L, x was known to us, and we have obtained the distribution of y. So what it actually differs over here, in previously for univariate, we are actually doing this thing. We actually have habit of taking transformation from x to y. For multivariate, we have like habit of taking transformation from x curl to y curl equals to some a into x curl or something like this. Here what we have done here is a multivariate setup. Here we have done the same thing, but instead of like not a curl, basically we have taken transformation like L curl transpose x curl or something like this. But here what we have taken, here we have considered that we have vectors like x curl, we have n vectors in vectors like x curl, and for all these vectors we have taken a transformation, and hence we have get generated y equals to this L into x. Okay, or rather to say, this is going to be a transpose, so basically this x into L. So based on this particular thing, this y consists of many y curls, this x consists of many x curl, and that number is basically my q over here, not p, these are my q over here, so not n, so we are actually assuming q vectors over here. So these are the difference between my univariate, then from univariate we have learned multivariate, and this is the highest step where we are dealing with many multivariate vectors, and we are assuming that all are following normal distributions of like p variate normals, so hence the order of the matrix and whatever dispersion matrix is pq cross pq. Is it clear?
Yes.
Okay, now we have some basic theories like the mean distribution, about mean, and these kind of notes. So before I proceed for the notes, let me write one or two things. Okay, then okay, this is a very important result which is a part of this syllabus. Okay, this is random sampling from normal mu curl sigma, where sigma greater than 0. This is the topic we are going to discuss. So we are taking a random sample from this. Okay, so let us assume that x1 curl p cross 1, x2 curl p cross 1, and xn curl p cross 1 be a random sample of size n drawn from normal p mu comma sigma. Okay, so basically this is what we are assuming. So my x alpha curl is x1 alpha. This is a particular vector, and we are just what I can say, like we are elaborating this particular vector as well, x2 alpha, and this is xp alpha. This is my vector which is supposed to follow np mu curl comma sigma independently. Independently for all alpha running from 1 to n, and we have n vectors such like this x alpha. Okay, and obviously we know what is going to be my data matrix. My data matrix is a matrix whose columns are made of with this kind of vectors, which is x1 curl p cross 1, which is xn curl p cross 1. This looks like this particular thing. Okay, so this is my X curl data matrix. Now we need to find the sample mean of the vectors. So let's go for the sample mean vector. Sample mean vector is X curl bar, which is 1 by n summation alpha running from 1 to n x alpha curl. So by n just a minute. Very sorry, today the class is like having too much trouble.
No, no issues.
Don't know what happened to the this particular software and this particular pen tab. I guess it's now visible.
Yes.
Okay, so what I was telling is the sample mean, I was discussing about the sample mean. So we have taken a random sample of this particular size n, and this is the formula of the random sample. And now what we have to do, we have to find the distribution of this thing. So this is one kind of transformation, like 1 by n summation of this x alpha. This is one kind of transformation, and we need to find the particular value of this, like the distribution of this particular transformation. So how we are going to find this particular transformation, that is very like interesting. So what we are going to do over here, we are going to try to write this x curl in form of basically one of the like transformation y equals to xl, which we have already learned, because that particular formula, like expressing this in form of a linear function, has already known to us basically. So if we can express this particular thing in form of this particular problem, so we can easily will be able to find out the distribution, and can actually refer from that distribution as well. So what we are actually writing this x curl as, we are writing this x curl as like this. So first I am writing this 1 by n. Is it okay? Can I write like this? This is x into L curl, where my L curl is 1 by n into 1 curl. Basically, this is my capital X, and this L curl is 1 by n into 1 curl. That is basically, it is 1 by n, 1 by n, 1 by n transpose. It should be written in a column. Due to the space constraint, I am writing it in a row. Is it okay? Can I write this whole thing in this manner?
Yes.
Okay, so it is nothing but again a linear function by using the whole thing. So I can actually find out the distribution directly as x into L curl follows np of m into L curl comma L curl transpose L curl into sigma, this thing, where my m into L curl is going to be 1 by n. Let me write this. Is going to be 1 by n to the 111, which I can write as my mu curl. Let me write a curl over here. And also my L curl transpose L curl is nothing but 1 by n. If L curl is this, obviously L curl transpose L curl will be 1 by n. So I can actually write this x curl bar actually follows this np of mu curl comma sigma by n. And what is a univariate form of this? If x follows normal mu sigma square, that implies x bar follows normal mu comma sigma square by n. This is the univariate form. And we this is a like multivariate form of this particular result, right?
Yes.
And also we can find out the distribution of the dispersion, and we know that in particular like in univariate case it is actually something like we can say that x bar and s square are jointly distributed and they are independently distributed. But here for finding out this particular things, we need to know some of the other like concepts which we have to go through parallel to this particular multivariate, which I am going to just brief out over here a little bit, which is one of the major thing over here is HOTELLING T-square statistics. Number one is HOTELLING'S T-square statistic. This is one particular thing. So it defines that we have y curl p cross 1 vector if it follows a p variate normal with mu curl and sigma, where sigma is pd. And also we have a matrix of order p cross p which follows a Wishart distribution of n comma sigma independently. Then this t square will be of the form where this small n into y curl transpose A inverse y curl will basically follow our t square prime p semi comma n comma lambda. Okay, and this is called my non-central HOTELLING'S t square. Okay, where what are the parameters? Where basically my this p distribution with I should write this with dimension p df, that is degrees of freedom n, and ncp non centrality parameter lambda, and which is my mu curl transpose sigma inverse mu curl. Now the question arises, like if this is like Hotelling T square, then what is my Wishart distribution? So Wishart distribution is the multivariate form of this particular distribution. So we can call it multivariate chi-square as well. Wishart distribution can be called as a multivariate chi-square as well. So let us discuss a little bit about Wishart distribution also. So before we go for this Hotelling T square, our another concept would be Wishart distribution. This is very important, or it is called generalized chi-square distribution. It is Wishart distribution, and it is very important in the context of this multivariate. So it defines that suppose we have a random matrix A of order P cross P, so it going to follow a Wishart distribution of dimension P with degrees of freedom n. So A is going to follow, A is what? It is a random matrix, is going to follow a Wishart distribution of dimension p with degrees of freedom n and parameter sigma p cross p if A can be expressed as, if A can be expressed as A equals to summation over alpha running from 1 to n, some Z alpha curl, Z alpha curl transpose, some one alpha dimensional vector into one alpha dimensional transpose of one other alpha dimensional vector, where I am defining this Z alpha curl are each and every one which follows p variate normal. The difference is, instead of mean mu curl, it has a mean zero curl. It follows like IID, and dispersion matrix is sigma, which is greater than 0 for all alpha running from 1 to up to n. The same thing, instead of like we were still doing the calculation with respect to x alpha curl, just I have changed the name. Instead of x, I have used this name z, and just instead of one changes over here, all of the time my x was following some mu curl and sigma. Here the mean is not following some mu curl, it is some zero curl, and like the mean is always null, and the notation is basically A follows Wishart P n comma sigma. So this denotes the dimension, this denotes the degrees of freedom, and this denotes the parameter. And obviously, if you can see, this parameter course is coming from the actual distribution of this particular vector, which is going to follow a p, and this dimension also comes from the dimension of this particular vector, that what is the dimension of this particular vector, that whether it is following a q dimensional normal or whether it is following a p dimensional normal. And the most important thing is, this A particular matrix should be written in this particular form. If we cannot express A, any randomly chosen matrix, in this particular form, then we cannot say that this is going to follow a Wishart distribution. Is it clear?
Yes.
And one of the important things which is coming from over here is that uh, number one is, if p equals to 1, like if dimension is 1, this is nothing but normal. So if p equals to 1, then basically A follows Wishart 1 of n comma sigma square as A is going to be of the form Z alpha square n running from 1 to n, where Z alpha follows IID normal 1 0 sigma square for all alpha running from 1 to n. So this is going to be my Wishart distribution of one dimension, and it is nothing, and we can write the same thing. A by sigma square is equals to summation over is equals to summation over alpha running from 1 to n.
I just
uh,
have a
yeah,
clarification.
yeah.
So chi-square we can use for univariate only. So in that case, when we have a multivariate data, for that we are
Yeah,
going to
it's
use a
multivariate
WISHART.
form. Yes, the multivariate form of chi-square, you can say in one word, it's a chi-square. That is, I am actually showing over here. Like, we can write this A by Z sigma square in this form. Okay,
Yes.
right? So, where my Z alpha by sigma is going to follow some normal 0, 1 IID. From here, actually, it follows from the above point.
Yeah. Yeah.
Okay, what is this A by sigma square, and what is, if this follows normal sigma square, so that is nothing but chi square in,
Yes. Okay.
and that is corresponding to my Wishart distribution with degrees of freedom in.
Okay.
And it has some particular properties which we are not going to discuss today, but this is how it is related with Hotelling t square distribution. And you can also say this Hotelling t square distribution, which we just stated above, is the multivariate form of the t distribution which we have learnt in the univariate case. Okay, so and if just we say we were saying that in this particular distribution we have just mentioned that this follows this mu, right? So if this mu particularly becomes my zero curl in a particular case, then obviously this lambda is going to be my zero, and then only this t will become a centralized Hotelling t square with dimension p and dfn, because the ncp then will become 0 if this particular distribution the mean is going to be 0. Okay, is it clear?
Can you please scroll down? I was making notes and I missed last.
Scroll down.
Yes.
Okay, this portion.
Yeah. 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 This only this one.
Wait,
A bit up.
a bit up. Okay.
Yes. Only one. Thank you. Can you scroll down? I just want to check.
Nothing is there, I just wanted to add one thing, then I will end up the class basically. Just one thing which I want to add is basically for this Hotelling t square, for this Hoteling's t square, if p equals to 1, then what will happen? Like, I am claiming you and telling you continuously that this Hotelling t square is the multivariate form of the normal t distribution which we know. So if p equals to 1, then y will actually going to follow normal 1 mu comma sigma square. Normal of 1 of, instead of p variate, it's going to be 1 variate, which is nothing but simple normal distribution of mu sigma square. And this A, which we have defined over here, is going to follow a Wishart distribution of order 1 n comma sigma square, which we have just proved is equivalent to some chi-square n distribution, and we have already mentioned that these two distributions should be independent. This was the statement of the Hotelling T square. I'm just going up so that you can see it once, right? If P is 1, if P is 1, this will be normal distribution of mu sigma square, okay?
Yes.
And if Wishart P is 1, then scrolling down and coming to this particular case where P is 1, this is giving me nothing but normal chi-square distribution. And what will
Yeah.
be the ratio of this y by sigma that is going to follow? Basically, normal with mu by sigma comma 1, and this a by sigma square is going to follow chi square n. Not y basically follows this. I should write this particular thing. This is not equivalent to, I should not write this particular thing over here. This will be like this. After taking the transformation, because there is a sigma over here. After taking the transformation, because we need to change this to 0 and 1 kind of thing, right? Then only we can take this to the normal t distribution,
Yes.
right? Now let me write the distribution of t square. So what is my t square? My t square was n into y square by a, and n into by sigma whole square by a by sigma square. Can I write the whole thing like this? Just adjusting a sigma square in the numerator and denominator. Then I am writing y by sigma whole square, a by sigma square whole divided by n. So what is the distribution of y by sigma whole square? It is something normal, mu by sigma 1, and it is chi square n by n, and its square root we can write if we remove the square from both the sides,
Right.
right? So it is equivalent to some t square distribution with n degrees of freedom.
Okay. Got it.
So t square over here, t square over here. Basically, it's a corresponding t distribution.
Okay.
Clear?
Yes.
So this is what why I'm just briefed out the multivariate cases. There are few more results which we can't discuss today right now. And sorry for the interruptions, whatever has happened in today's class due to some technical glitches
No, no.
and problems. And extremely sorry for that. So if you have any queries, you can please ask me.
I don't have any query, but I just wanted to know in general, do we get the recordings of the classes?
Yes, you are supposed to get the recordings of the classes and even the notes, even the PDFs, whatever I am writing in the board, you were supposed to get that because I sent the same thing in form of the PDF, and I actually shared this to the sirs, with sir, and you can collect it from sir's. You can ask sir regarding today's class note and today's recording,
Okay.
and if you have any doubts further after seeing the notes and recording, you can also communicate the doubts to sir's query section, and they will actually give me the doubts, and I am going to clear the doubts in the class. Okay.
Okay. Okay. Okay.
Okay.
I'll ask.
So okay, please ask them for the notes and the doubts, and doubts and handwritten notes and the records, whatever I share in the class. Please, you can ask them everything. I after the class,